Hello, my name is Zubair.
And my name is Ekene.
Today we're going to be showcasing our assignment 2, processes, signals, and pipes, starting with running our program and showing it compiling and executing successfully.
Okay, so as you can see, the program runs successfully here. Now we're going to show you the test cases. So on the left side we have the reference shell, and on the right side we have our shell. So this is from test 1 to test 4. You can see from test 1 to test 4.
They all running successfully side by side. You can see them.
All our tests run successfully.
All 17 of them are running without issue.
So this is from test 5 to test 7. You can see test 7.
Left hand, you can see it as well. 5 through 7.
From test 8 to, you can see test 8
running well as well. They're both right there.
8, 9, 10. This is 10. Moving on to 11.
11's there. 12 is there.
12.
Test case 13 will show you at the end. It's also running successfully, but we'll get to it at the end.
Okay.
And here you can see 11, 12, and then 13 will come back to later. But 14 here is running.
Racing. Okay, this is 13.
There's 13 and 14 right there.
Okay, this is
all
14.
Running successfully. You can see them side by side once again.
Okay, so this is 14 side by side. So this is 15.
Scroll down a little bit. Show them 15.
And this is 15, putting it all together.
Yeah.
16, 17.
Then there's 16 and 17 running successfully. Now we'll scroll up a little bit to 13 so we can show 13 passing side by side.
So
okay, great.
Yes, hopefully we've been able to convince you on that. So now we will
move on to the code walkthrough. Alright,
here's the code walkthrough. So at the beginning of the file, actually we'll start with the evaluation function. We get the argument command line, and then we pass through it and get the number of arguments in the command line. So if there's a built-in function, we do not run the rest of the evaluation, and we just execute it right away. And if there is not, which is in this case, we check for the ampersand value and then set our indicator variables as accordingly. We truncate the list with the helper function to remove the ampersand function for the sub process, the child process. If it's a foreground process, if there's no ampersand, we set our variable to a foreground process. So in this step, we block the we block the main process from receiving sick children signals until it's time to add the child to the list of jobs. And so here
what's the time looking like?
Here we check for the inputs redirection symbols
with those specific characters for the indexes
with our helper function, yes. And here we fork. After forking, we get the parent ID and set the process group ID of the we set the process group ID for the child. After this is done, we send the sig user signal to the parent ID to notify it. Now, if there is this is the pipe index, we shall come back to this for a walkthrough after. We'll talk about pipes. So now in this step, we check if there's an input symbol or an output symbol, and in those cases we use dupe to accordingly to set standard in and standard out file descriptors. So in this step, we reduce the size of we adjust the size of the or rather we slice the command line if there is an input symbol. Where is that? Actually, it's not here. If there's an input symbol, we slice it accordingly. So once we get our sliced arguments list or our sliced command line, we execute. That's here. But before we do that, we have to unblock the signal masks. And then this is just some error checking. Here in the parent process, we add the job and then we unblock to get the sig child. In this case here, we suspend until we know that the child has set its process group ID, and then After this is done, we move on with our program. If it's a foreground process and it has not terminated, then we continue waiting for it.
Mm-hmm.
If it's a background process, we set its state accordingly, and then we let the user know, and then we just reset ready as needed. Now in this, these are just our helper functions to check for a character in a string and to reduce the list of a dynamically allocated list of characters. So now in the built-in commands, we do some error checking to see that each built-in command has the appropriate number of parameters and arguments sent to it. And in this, the do bfgfg, we just do the same thing. We check if there's if there's a percent sign, and we use this is JID and this PID to indicate those. And once we have those sets, once it's time to, once we send the sig cont with the kill command, we check if it's a background or it's meant to be a foreground process, and then we wait or let the user know accordingly. Again, there's not much time in this to go through all that, but yeah, in the sig child handler, we reap all the processes here in the while loop, and again we use no hang and untraced for the wait PID to return immediately, and for it to catch 6 stop signals. And so if it's exited or we receive the sig ins, then we delete the job. If it's stopped, then we just change its status here. If this is the parent process, this is if there's a foreground process, immediately we check its status, check if it has been sig stopped, here. If it's stopped, then we change it accordingly, or if it's exited, we just delete the job. And yes, so again, most importantly, we do not hang in the wait PIDs. This is a sig int handler. We just send the sig ints to the process group ID of the foreground process using FGPID, and then the sig stop handler, we do the same thing. We send sig stop to the process ID of the group process ID of the child process, of the background of any of the foreground process, and then we let the user know accordingly. And this is just the sig user handler. And yeah, so hopefully I've been able to convince you on that. What's the next?
Now we're gonna showcase the pipes.
The pipe. So here on the pipe walkthrough,
just a little bit go down a bit. I think it was right there.
This is where it is. Just a little piece of code. But yeah, here we just we truncate the list to be just before we divide the argument list into 2 parts. So the part before the pipe and the part after the pipe. The process after the pipe symbol is going to be the foreground, and the one before is going to be somewhat of a background process. So we set our file descriptors accordingly, and then we use pipe to initiate it. And so we fork the child process, and then we adjust its standard in and standard out accordingly for both sides of the child, for both children of the fork, for both sides of the fork.
Yeah.
So we close our close the file descriptors as needed, and this is just a usual pipe function.
Okay, now we're gonna showcase our testing for our pipe code.
All right.
The additional tests.
Yeah, there was a bit of issue here, but yeah. Okay, so these are just the additional testing. So here we designed a wait function, a special wait function. It should be here. Yeah, just to wait for a specific amount of time, right? And so here we we wait for these amount of seconds, and then we just stop and check the job. As you can see, the process has been stopped, and then we run background on the job ID, and then you check jobs and it's running again, and then we bring it to the foreground. As you can see, the blocks, and then we use Ctrl+Z to stop it again, and we check the jobs again and it's been stopped. And then we use, here is a testing for our pipe. We use ls and the usual grep, and because you can see it returns the files that have the words source on them. And here is our pipe, our output redirection, and here's our input redirection. So we use cat to print everything out, as you can see. And back here we use sorted to in the case that both symbols are present. And yeah, this was an issue because sorted is not an actual executable. Same thing here. But here we get it running. This is the correct prompt, and then as you can see, this is just the output from sorts, and it sorts everything in alphabetical order. And yeah, so this
that's our additional test for piping.
That's our
pipes, as you can see, works
for
well.
pipes and like all the test cases in general. And what's the next?
Now we're going to talk about issues encountered. So yeah, that was our code walk through our tests. Now let's talk about the issues encountered real quick. So the first main issue that we encountered has to do with how the child process is received. So practically, originally, the child handler would hang when the child process received a sig stop signal, right? So what we did was, in order to fix this, we fixed it by adding a no hang option and untraced options. So that would fix that issue with the child hanger. And then another issue that we encountered that took some time solving was at the beginning processes weren't a SIGINT and sig stop handlers would use the kill command to send commands to the FG process. However, this would not terminate the entire process, so we had to work around this. And the way we worked around this was by setting up and changing it from kill to kill PG and using that function instead for it to run effectively.
Yeah, that was what we used to send a signal to the whole process group. And yeah, that's most of that. So for the
we need to talk about how we split up the teamwork for the assignment.
Yeah, so for the teamwork, I handled the the signal management, as knowing when to block and unblock signals, how to handle the masks, and knowing how to handle the sig suspends, and also the handlers themselves, and what to do with what options to use in the wait PID functions.
So that's what he did, and then what I did was I handled and completed the file input and output redirection, as well as the code for the pipes, right? So that's what he did, that's what I did. We tried our best to split it 50-50, and yeah, that's our code running successfully, the code walkthrough, and then issues encountered and our teamwork, and that's the video. Thank you so much.
Thank you.